Welcome to EDU World Space.
In this problem, we are told that the planet Uranus has a radius of 25,560 kilometers and a surface acceleration due to gravity at 11.1 meters per second squared at its poles. Its moon Miranda is in a circular orbit at an altitude of 104,000 kilometers above the planet's surface, and we're given the mass and radius of Miranda as well. And we're asked to go through and calculate a series of things about this system. So in part A, we are going to calculate the mass of Uranus from the given data. So let's go ahead and write out some of the givens. So we know what the acceleration due to gravity is. And we also know what the radius of Uranus is. That was given as 25,560 kilometers. So that ends up being 2.556 times 10 to the 7 meters. And this is enough information to go ahead and calculate the mass using the formula for the acceleration due to gravity. So the acceleration due to gravity is gmm over r squared. And so we can rearrange the formula here by multiplying by r squared and dividing by g. Big G, that is. And that will give us the mass. So we're just going to plug in our values. So we've got 11.1 times 2.556 times 10 to the 11 squared, all divided by 6.67 times 10 to the minus 11. And so once you plug that into a calculator, oops, sorry, this should be 7. Once you plug that into a calculator, you should get a mass of 1.09 times 10 to the 26 kilograms. So this is the final answer for part A. In part B, we are asked to calculate the magnitude of Miranda's acceleration due to its orbital motion about Uranus. So we know that the gravitational force on Miranda is going to be gmm over r squared. But we also know that force is equal to mass times acceleration. And so this gives us a formula for acceleration. Acceleration is gm over r squared. We do have to be careful now, though, because the r is a bit different than the r in the previous section of the problem. So in the previous section, we were just using the radius of Uranus. In this section, we need to be using the distance between the center of Uranus and the center of Miranda. So we're going to add the 25,560 kilometers and the altitude of Miranda, 104,000 kilometers. So together, that's going to give 129,000 kilometers, 129,560 kilometers, or we can also write that as 1.2956 times 10 to the 8 meters. Okay, so now that we have that, we can just go ahead and plug everything in using that newly found mass that we discovered, 0.09 times 10 to the 26 and dividing by that radius. So that gives an acceleration of 0.433 meters per second squared. So this is our final answer to part B. And this is the acceleration. It's basically the centripetal acceleration, right? It's the acceleration that an orbiting body has because it is moving in a circle. In part C, we are asked to calculate the acceleration due to Miranda's gravity at the surface of Miranda. So this is a similar calculation to the ones we've just done. We are going to still use G equals gm over r squared, but now we're going to use the data that pertains to Miranda specifically. So the mass was given as 6.6 times 10 to the 19 kilograms, and the radius is 235 kilometers or 235,000 meters. So let's go ahead and plug everything in here. And so once you plug that into a calculator, you get quite a small value. It's 0.08 meters per second squared. And so this is our final answer for part C. Finally, in part D, we're asked if the answers to part B and C mean that an object released 1 meter above Miranda's surface on the side toward Uranus will fall up relative to Miranda. So basically what this is getting at, and I think it's probably best to look at a picture, is we've got our planet Uranus, we've got our moon Miranda, and we let an object go 1 meter above the surface of Miranda. So it's going to have an acceleration towards Miranda of 0.08 meters per second squared, and then an acceleration towards Uranus of 0.433 meters per second squared. And so that might lead you to think that, okay, there's a bigger acceleration, downwards towards Uranus or up relative to Miranda. So it's going to start moving up relative to Miranda and towards Uranus. But the problem with that type of reasoning is that you are forgetting that the moon Miranda is doing a circular orbit. And so the object as well, since it's associated with Miranda, is also doing a circular orbit about Uranus. And so this acceleration, 0.433 meters per second squared, just goes into creating that circular motion about Uranus. So if you're standing on the surface of Miranda, you would still see the object moving towards Miranda or falling down relative to Miranda using this acceleration here. So that is the final answer to this question.